My name is Theo Ra, and this is my lab video report for Lab 1 on constant velocity. This is what the video will cover, starting from introduction all the way to conclusion. The purpose of this experiment is to compare the observation of an object with constant velocity with an expectation through a computational method. Here are the related concepts to this experiment. Constant velocity is the state where net force is zero and none of the aspects of velocity of the system, direction, and magnitude changes. Newton's first law is that when there are no external net force, that is, the net force is zero, an object in rest stays in rest, and motion stays in motion. This is the explanation for the constant velocity earlier. Newton's second law states that the net force is mass divided by acceleration. When net force is zero, the acceleration also becomes zero. Here are the formulas that were used for this experiment. The velocity update formula states that final velocity equals initial velocity plus f net over mass, which is acceleration, times change in time. When net force is zero, the change in velocity is also zero. The position update formula states that final position equals average velocity times change in time. We'll use this to calculate object's position in the computational model later. The average velocity formula is that average velocity equals change in position over change in time. We'll use this to calculate the initial velocity in the model. This is a preview of the result of the experiment. We can see that the observation showed that the object traveled in constant velocity with zero net force. This is the image of the experiment and the component. The object or system is the metal part of 13.5 centimeters in length. And the surroundings are everything else that interacts with it, like the rail with friction, the earth with gravity, and so on. The experiment procedures were one, taking a video of the cart rolling in constant speed, two, analyzing the video through tracker program, three, making a computational model for prediction through growth script, and four, comparing the results in Excel. This shows the initial conditions I was able to get from the tracker program. As we can see, the observation started at 0 seconds and the initial position was negative 0.0041102285 on the x-axis. Then we can calculate the initial velocity by dividing the difference in position between the first two observations by difference in time between the first two observations. The observation went on for approximately 2.7 seconds with approximately 85 observations. This is the video of my tracker analysis. This is how I set my initial conditions for the GlowScript program. The mass, first of all, does not matter because the net force is zero. For position and velocity, I use the initial conditions from tracker. Delta t was 0.033 seconds as the tracker did, and the loop length also equaled the observation time. Finally, I use position and velocity update formulas, change them respectively in the program. This is the video of my GlowScript program running. Then I put these data into Excel program and compared them in a single graph. We can see from this that our prediction through the GlowScript and the actual motion we observed through the tracker is very similar. This shows that the object traveled in constant velocity with zero net force, which supports Newton's second law. There are some deviation in the latter part, let's address that. What were the possible sources of this error? One is human error that I made as I was plotting the mass points in tracker. I might have accidentally plotted them farther apart than they actually are, or the other way around. Second, the external forces we regarded as zero, like friction and air resistance, might come into play. Finally, the rotation of camera angle might have messed the results up. Questions. If axis was flipped, what would happen? Since the coordinates would be decreasing into minus x direction, the slope of the graph will change from positive to negative. However, the net force is still zero and velocity will stay constant and graph will be straight line. How many forces come together to create zero net force? There are the fact that there is zero net force does not mean that there are no forces acting. The gravity and normal force would cancel each other out, and there are many other forces. Therefore, I cannot say for sure how many forces, but the net force is zero. Conclusion, Newton's second law was supported.